Good morning, students. So we are done with the first part of the class 12 physics. Now second part, and the starting is from chapter number 9, ray optics and optical instrument. Okay, so the light chapter has been divided into two chapters. The light unit is divided into two chapters. Optics, basically, the first one is the ray optics. Optic is basically the study of light. First we have ray optics and optical instrument. Okay, optical instrument is equally important. Definitely microscope and telescope, one question will be there in exam. Okay, and the second chapter of optics is the wave optics. So why we have this division? Because the it was always a mystery of what light is. Okay, earlier it was considered made of corpuscles, that are particles, by Descartes and later Newton. And it says that light is a particle, it moves in straight line in the form of ray. Okay, and it explain all the things. It was explaining reflection, refraction, all those things were easily explained from through it. Okay, so light was considered particle earlier. Okay, there was no confusion in that. But later, what happened? Certain phenomena like diffraction and then interference, young double slit experiment that you study in the second next chapter, those were not able to understand what this light theory or the ray theory was not able to explain those phenomena. So then hygiene came with an idea that light is not a particle but wave, and those phenomena was easily explained, and he was able to explain reflection, refraction, considering light as wave. Okay, but again, when the optics will be completed, we will enter in the modern physics, that is the dual nature of light. Okay, then we will see that light, some more phenomena like photoelectric effect. Okay, it is very simple phenomena, but the classical theory or the wave theory was not able to understand this photoelectric effect. Then Einstein come with an explanation that let's take light as packet of light, photons. Okay, and treat light as a particle, and he was able to explain photoelectric effect. So what's the problem? Light sometimes behave as wave. Some phenomena can be explained as light, considering light as particle, some as wave. So we have dual nature of light that we'll discuss in the modern physics, dual nature of matter and radiation. For now, we have ray optics, and in this chapter there is no mention of wave. We will consider light as ray. Okay, with particles moving straight line. This all thing is about this. You know the speed of light. It is 3 into 10 to about 8 meter per second. Actually, this is vacuum. This is 2.99, very pretty close to 3 into 10 to about 8 meter per second. Okay, and this certain topics from here, it is related to class 10th. So I will suggest you to go through those chapters if you don't know those topics. Otherwise, it will be revision of those topics. Reflection by spherical mirror, you know, incident ray, reflected ray, normal, no? This is the perpendicular line drawn to the point of incidence. Okay, then we have laws of reflection. Incident ray is always equal to reflected ray. Then we have the sign convention. Okay, I'm going to this too far in this, not explaining in detail, because this was already in class 10. Okay, so you see that in the left side, these are taken negative, height above principal axis normal, this taken positive. Those are the sign convention that you need to understand. Focus, what is focus? Is a point on the principal axis. The principal axis is a line passing the center of curvature and pole. And what is center of curvature? Is a point of the center of the spherical hollow glass sphere of the mirror is a part. As you all know, focus is the point where the line parallel to principal axis after reflection meet. For a concave mirror, for a convex mirror, it is a point where light rays which are parallel to principal axis after reflection appear to be coming from. It is a virtual focus. This convex has a virtual focus. This is the real focus. Focal plane is the point, is the plane in which the focal focus will be there. Principal focus will be there, and the principal focal length, this is the focus from pole is focal length. This is half the radius of curvature, this all thing you know. There is the mention of paraxial rays, that will be the very important thing. I think I'm not sure where it is given, but is given. So those rays which are very close to principal axis, we will consider those as paraxial rays. Okay, and what paraxial rays, the angle will be, all this angle of incidence, angle of reflection will be very small. That will be pretty handy for our derivation. We will take this assumption, and this is the important line here. It is written here. Okay, I'll just highlight this. We assume that the rays are paraxial. I think some question has been asked in board related to this. They are incident at points close to the pole of the mirror and make small angle with the principal. Very important. So where all our assumptions are based that the rays are paraxial. What are paraxial? They are very close to the principal axis. Okay, and the angle they will make will be very small. So we'll approximate sine theta is equal to theta, tan theta is equal to theta, because the angles are small. The reflected ray converts at a point on the principal axis. This again, this is the thing I told you. This was the explanation that you need to do. Then they are just explaining that how we arrive at the focal length is equal to r by 2. So again, the angles are small. Okay, not very important. Okay, what is important is this is important. The mirror equation that you already know. What is mirror equation? This is 1 by v plus 1 by u is equal to 1 by, what is v? V is image distance, u is object distance, and f is focal length. The derivation has been asked in boards and can be asked again. So it is nothing but through the similar angle, similar triangles. Okay,